This is Chemistry, Unit 4, Chemical Nomenclature. Ionic compounds with polyatomic ions. Some ionic compounds contain polyatomic ions. These are ions with more than one atom. A list of these will be provided to you for your reference, and it looks like this. Many polyatomic ions contain oxygen, so they're referred to as oxyanions. And naming ionic compounds that contain polyatomic ions involves using the naming rules of type 1 and type 2 ionic compounds. So the first step, again, is to name your metal or ammonium, which is NH4 with a +1 charge. It is a positive polyatomic ion, and it's right here on your chart. So this is a positive polyatomic. All of the others on this chart are negative. So these will be used as your anion in the formula. Now, the second step is to determine the type of metal. So if the metal is from group 1, which are the alkalis, group 2, alkaline earth, or is aluminum, zinc, or silver, then no Roman numeral is used. So remember, you have your type 1s labeled. If the metal is not from group 1, the alkalis, group 2, the alkaline earths, or is not aluminum, zinc, and silver, then you use the Roman numeral. So these are your type 2s. Third step is to name the polyatomic ion. So let's practice. Silver nitrate. So silver, you have to look on your table, has the formula Ag, and it's type 1, so we know the charge. There's no Roman numeral written, so it's Ag +1. Now nitrate, you have to get used to looking on this chart. Nitrate is over here, and the formula is NO3 -1. So when I'm originally writing these down, I like to keep my polyatomics in parentheses, but you will not always need that parentheses in the final formula. So I will let you know when it's necessary. So here we have Ag +1, NO3 in parentheses -1, because it's that entire parentheses that has the -1 charge, not just the oxygen, because the -1 is written near it. And what this means is that silver can lose an electron, nitrate can gain an electron, and these are both a 1-to-1 ratio. So if you exchange these, it simply stays 1-to-1. So your final formula is AgNO3. The 1s are not written, your plus or minus is not written, and you don't need any parentheses here because no charges were shown in that final formula. Next, manganese 2 acetate. So manganese has the formula Mn, and it's type 2, which is why you see the 2 Roman numeral written here after manganese. And then acetate. Now acetate can actually be written in 2 different ways. C2H3O2 or CH3COO, but either way you still need to include that -1 charge. So here's the way I write these down. You have Mn +2, my Roman numeral 2, and then I just chose the first one, the first version. It really doesn't matter which one. So I have C2H3O2, and I like to keep that in parentheses so you understand that that entire polyatomic has the -1 charge. Now this means manganese can lose 2 electrons, and each acetate can gain an electron. So to make this neutral, you need 2 acetates to make this possible. So when you exchange it, it's Mn parentheses C2H3O2 parentheses 2. So in this case, you do need the parentheses because if you didn't write that, it would be oxygen 22. So this parentheses indicates that I needed 2 acetates to balance this out. The 1 is not written, and your plus or minus is not written. Next, ammonium phosphate. So again, careful, ammonium is our positive polyatomic, which is right here, so it's NH4 +1, and our phosphate is PO4 -3. So let's go ahead and write these down first. And again, I like to keep my parentheses when I'm initially writing these so that you know the charge applies to the entire polyatomic. Now, ammonium is +1, so that can lose an electron, And then phosphate is PO4 minus 3. So each phosphate ion can gain 3 electrons. So to make this neutral, you need 3 ammoniums to balance this out. So the ammonium will keep its parentheses. So it's parentheses NH4 parentheses 3 and then PO4. So you don't need to write the 1 and you don't need to write your plus or minus. Okay, one more. Potassium permanganate. So potassium has the symbol K and it's type 1, so we know the charge is +1. And then permanganate is a polyatomic and it's right here, MnO4 with a -1 charge. So here we have potassium at +1, so that can lose 1 electron. MnO4, I kept it in parentheses, so you know the entire MnO4 can gain an electron. So this is a nice even exchange. No parentheses needed, no ones needed, no plus or minus. It's KMnO4. Now let's try the reverse. You have the formula, and I need the name. So we start with our metal, and our metal is K, which is potassium, and it's type 1, so I don't need a Roman numeral. Now ClO3 is a polyatomic. It's not chlorine oxygen. So you have to look up ClO3 on your chart, and ClO3 is called chlorate, and it has a -1 charge. Potassium and chlorate, no Roman numeral needed, so you just write potassium chlorate spelled correctly. Next, CONO3 2. So CO is actually cobalt, and cobalt is in my type 2 section, so I will need a Roman numeral. Now NO3 is nitrate, and it has a -1 charge, and we're going to need that to solve for our Roman numeral. So you solve this the same way you solved it for your type 2s, except your anion now is a polyatomic, but the charge is still known. So cobalt is my unknown, so I have 1 cobalt in the formula, and it's the unknown Roman numeral, so it gets the X. I have 2 nitrates, right? There's 2 on the outside of that parentheses, and nitrate has a -1 charge. That's on your reference list. So the first thing I do is multiply my numbers. So 1x remains the same. 2 times 1 is 2, and it keeps its negative charge. Next, I move the 2 over to the other side to isolate my x, and then to solve for x, I divide by 1, and that leaves me with x equals 2. So that means my Roman numeral is 2. So the correct name is cobalt 2 nitrate. AuOH3. Au is actually gold, so it is type 2, so we will have to determine the Roman numeral. OH is hydroxide, and hydroxide is on your chart. It's right here. It's OH, and it has a -1 charge. So to solve for the Roman numeral, X is my unknown. That's the gold, which we don't know, and I have 1 in my formula. I have 3 OHs, right? That's what that parentheses means. There's 3 of them, and OH has a -1 charge. Next, you multiply your numbers. So 1x remains the same. 3 times 1 is 3, and you keep the negative charge. Remember, it equals 0 because we want this to be neutral. Next, I move the 3 to the other side where it becomes positive, and then I will solve for x. So x is 3. So this means that my Roman numeral for gold is 3. So this is gold 3 hydroxide. All right, next I have MnSO4. So Mn is actually manganese, and manganese is type 2, so again I will have to determine the Roman numeral. Now SO4 is a polyatomic. Right here it's called sulfate, and it's SO4 and it has a -2 charge. So let's solve for the Roman numeral. So Mn is my unknown, that's the X, and I have 1 in my formula. SO4, there's no parentheses here, right? So that means I have 1 of them, and the charge of SO4 is -2. So the first thing you do is multiply your numbers. So 1x remains the same. 1 times 2 is 2, and you keep that negative charge. Next, you'll move the 2 to the other side where it becomes positive, and then you solve for x. X equals 2, so the proper name is manganese 2 sulfate. And this is how you write your polyatomic ion formulas.